Hello students, in this video we are going to discuss about how do metals and non-metals react with each other and what will be the nature of the resulting compound. You know that all elements participate in various chemical reactions in order to attain stability, that is, to attain a completely filled valence shell. In order to attain stability or a completely filled valence shell, the atoms of these elements either lose or gain electrons while participating in various chemical reactions. Thus, metals generally have a tendency to lose electrons, whereas non-metals generally have a tendency to gain electrons while participating in a chemical reaction. For example, let us consider the case of reaction between sodium and chlorine to form sodium chloride. Here, sodium is a metal and it has a tendency to lose electron while participating in a chemical reaction. The electronic configuration of sodium atom is 281. If the sodium atom loses one electron from its valence shell, the remaining part of its electronic configuration contain completely filled shells. Thus, by losing the one electron from the valence shell of sodium atom, it will attain stability. At the same time, chlorine is a non-metal and it has a tendency to gain electron while participating in a chemical reaction. The electronic configuration of chlorine atom is 287 and it has 7 valence electrons in its outermost shell. If it gains one more electron, the outermost shell becomes completely filled. Thus, after the gain of one more electron, the chlorine atom will attain stability. When an atom loses one electron, it is converted to a positively charged ion or cation. At the same time, when an atom gains one electron, it is converted to a negatively charged ion or anion. The magnitude of charges on these ions depends on the number of electrons gained or lost by that atom. In the case of sodium atom, the electronic configuration is 281 and after losing one electron, it is converted to Na plus ion, that is a positively charged ion or cation, and its electronic configuration is 28. So this is a stable electronic configuration. Next, in the case of chlorine, the electronic configuration is 287. And after gaining one electron, it is converted to Cl minus ion, which is an anion, that is a negatively charged ion, and its electronic configuration is 288. This electronic configuration is also stable. Thus, sodium is converted to Na plus ion, that is positively charged ion, and chlorine is converted to Cl minus ion, that is a negatively charged ion. Na plus ion is called sodium ion, whereas Cl minus ion is called chloride ion. The sodium is converted to a positively charged ion Na plus after losing one electron, and chlorine is converted to Cl minus ion after gaining one electron. When sodium reacts with chlorine, sodium will donate one electron to chlorine. These are the Lewis dot structures of sodium and chlorine atom, and in Lewis dot structures only valence electrons are represented as dots or crosses. So sodium atom has only one valence electron and it has a tendency to lose that electron. At the same time, chlorine atom has 7 valence electrons in its outermost shell and it needs one more electron to complete its valence shell. So sodium atom donates one electron to chlorine atom. As a result, sodium is converted to Na plus ion and chlorine is converted to Cl minus ion. These are two oppositely charged ions and they bind together by electrostatic force of attraction, and it exists as NaCl or sodium chloride. Next, Let us discuss the reaction between magnesium and chlorine to form magnesium chloride. Here, magnesium is a metal and it has a tendency to lose electron while participating in a chemical reaction. The electronic configuration of magnesium is 282. If the magnesium atom loses 2 electrons from its valence shell, the remaining part of its electronic configuration contains completely filled shells. Thus, by losing the 2 electrons from the valence shell of magnesium atom, it will attain stability. At the same time, chlorine is a non-metal and it has a tendency to gain 1 electron while participating in a chemical reaction. As a result, it will attain stability as explained in the previous example. The electronic configuration of magnesium atom is 282 and on losing 2 electrons, it is converted to Mg2 plus ion, which is a positively charged ion or cation, and it is called magnesium ion. Its electronic configuration is 2,8 and this is a stable electronic configuration. At the same time, the electronic configuration of chlorine atom is 287 and after gaining 1 electron, it is converted to Cl minus ion, which is a negatively charged ion or anion, and its name is chloride ion, and its electronic configuration is 288 and this is also a stable electronic configuration. In order to attain stability, magnesium loses 2 electrons. At the same time, chlorine atom gains 1 electron. Next, we can consider the reaction between magnesium and chlorine. These are the electron dot structures of magnesium and chlorine atoms. And in these electron dot structures, only the valence electrons are represented as the dots or crosses around the symbol of the element. In order to attain stability, magnesium has a tendency to lose 2 electrons in its valence shell. At the same time, chlorine has a tendency to gain 1 electron. So, in order to accept the 2 electrons lost by the magnesium atom, 2 chlorine atoms are required. Thus, magnesium atom will donate each of these electrons to 2 chlorine atoms. Thus, magnesium is converted to Mg2 plus ion. Since magnesium lost 2 electrons, it is converted to Mg2 plus ion. The magnitude of the positive charge depends upon the number of the electron lost by that atom. At the same time, each chlorine atom will gain 1 electron from the same magnesium atom. Thus, each chlorine atom is converted to Cl minus ion and it can be represented like this, Cl minus twice. Okay. So, these are 2 oppositely charged ions. So, they are held together by electrostatic force of attraction and as a result they exist as MgCl2 or magnesium chloride. The compounds formed in this manner by the transfer of electrons from a metal to a non-metal are known as ionic compounds or electrovalent compounds. Thus, sodium chloride and magnesium chloride are examples for ionic compounds or electrovalent compounds. Next topic, properties of ionic compounds. And the first one, physical nature. Ionic compounds are solids and due to the strong force of attraction between the positive and negative ions, they are somewhat hard. They are brittle, that is, on applying pressure, they are break into pieces. Next property, melting and boiling points. Ionic compounds have a strong interionic attraction and a large amount of energy is required to break the strong interionic attraction. As a result, ionic compounds have high melting and boiling points. Next property, solubility. Ionic compounds are generally soluble in water and insoluble in solvents such as kerosene, petrol, etc. Next property, conduction of electricity. A solution of an ionic compound in water conducts electricity due to the movement of positively and negatively charged ions present in it. On passing electricity through the solution, these ions will move towards oppositely charged electrodes. For example, this is a setup for testing the conductivity of a salt solution. Salt solution means solution of an ionic compound such as sodium chloride, and electricity is passed through the solution by means of two electrodes which is connected to the positive and negative terminal of a battery through a bulb and switch. When electricity is passed through the solution, the positively and negatively charged ions will move towards the oppositely charged electrodes. Thus, the solution conducts electricity and the bulb starts glowing. Thus, movement of ions is very important for the conduction of electricity by the salt solution. Movement of ions is not possible in the solid state of ionic compounds due to their rigid structure. Thus, the ionic compounds in the solid state do not conduct electricity. But in the molten state, ionic compounds conduct electricity. It is because in molten state, the electrostatic forces of attraction between the oppositely charged ions are overcome due to the heat. Thus, the ions move freely and conduct electricity. These are some important properties of ionic compounds. I hope you understood the topic. Okay, thank you.